Hello everyone, hope you're all doing well. This video is going to talk about the quadratic formula, which is another method to solve quadratics. So we've learned multiple ones already, but quadratic formula is one that it's not too difficult once you get the hang of it, and the nice thing about it is that it works every single time. So you guys know that when you're factoring, sometimes you run into situations where you are unable to factor. And if you use the quadratic formula instead, you would come up with an answer, whereas factoring you're not. So quadratic formula is sort of my go-to because you can always use it no matter what type of roots you have. And today we're just going to talk about the first part of it, which is the discriminant. Alright, so let's talk about the quadratic formula. Really nice and big in your notes. Let's go ahead and write this down together. So here we have x is equal to negative b plus or minus the square root of b squared minus 4ac, and those three things, 4a and c, are all multiplied together, all over 2a. And that fraction bar should cover that entire piece in the numerator. So negative b plus or minus the square root of b squared minus 4ac all over 2a. After you guys submit this assignment, there is a very catchy song, quadratic formula song, that I want you to watch, so you'll never forget this again. But for right now, what we're going to just talk about is the discriminant. So the discriminant is just this component up here, the part that is underneath the square root. So by knowing what that value is, b squared minus 4ac, by knowing what we get out of that, we have a few options for what our solutions or our zeros are going to be. So your discriminant is, if Miss Hanley can spell, b squared minus 4ac. Just this part is the discriminant, alright? And in the next slide, we're going to talk about the discriminant as the variable d. Doesn't relate to part of the equation, but it's just stands for discriminant. So the d is the b squared minus 4ac. And another note, the place that we get b, a, and c would just be from a quadratic function, like ax squared plus bx plus c. So a standard form quadratic equation, not a vertex form. You have a, b, and c, and then you're just filling in those variables all along. And it gives you your two x's, which are your solutions, or your zeros, where your graph crosses the x-axis. Remember, there might be two, there might be one, or there might be none. And so let's go look at what that looks like in the next slide. Alright, so I'm going to talk through the information on this chart, and then I want you guys to pause the video and copy this chart into your notes, because this will be really, really helpful to you and really important. So in the very beginning, the first box, it says D, and that stands for the discriminant, remember? So if you get a discriminant that's greater than 0, you plug in b squared minus 4ac, simplify it out, and you get a number that's greater than 0, meaning it's positive. So maybe you get 5. But this says that it's a perfect square, so let's say we get a number like 16. That tells us that we're going to have two real rational roots. So what it means to be rational is that you can write it as a fraction, right? And real means that they're not imaginary. So we're starting to get into the world of imaginary numbers. But if you get a positive discriminant that's a perfect square, you're going to have two real roots. Oops. I need to cross that out. Two real roots that are also rational. And as you can see by the diagram, that means that they're going to cross the x-axis in two different places. And they might be fractional, but they'll not be a crazy number like pi or the square root of 2. The other option is to get a positive discriminant, d is greater than 0, but it's not a perfect square. So maybe this time we get 5. All right, and that means you're going to have 2 real roots. Oops. But this time they're going to be irrational. So a number that's not a repeating decimal or can't be written as a fraction, so it just keeps going and going and going and has no rhyme or reason to it. So those you'll have to estimate when you're graphing. So you still get 2 real roots, meaning it crosses the x-axis twice. 2 zeros. But the first one you get rational roots, and the second one you get irrational roots. Alright, well, the answer could be positive, so that's the first thing we can look at. We can also get a discriminant that's equal to 0. B squared minus 4ac might actually equal 0. When that happens, you're going to get 1 real root, and it's called the double root, because even though it's only showing up once and we're only getting 1 answer, because it's coming from a function that started with x squared, we should always have 2 answers. So what that really means is that we're just getting that solution twice. So that's why we call it a double root. So if your discriminant equals 0, you get 1 real rational root. So it's only crossing the x-axis once, meaning you have 1 0. Oops. Alright, and then the third option is to get a number that's less than 0. And you guys know by now that anytime you put into your calculator the square root of a negative number, well, your calculator tells you that there's an error, right? That's because this number is imaginary. So the square root of a negative, square root of negative 4, for example, square root of 4 is 2, and the square root of a negative is I, becomes an imaginary number. Imaginary numbers, imaginary zeros, don't cross the x-axis. So you have 0 zeros, 0 real roots. But just because you have 0 real roots doesn't mean you don't have any. You actually have 2 complex roots here. So I'm going to add something to this, that we have 0 real roots, but we do have 2 complex roots, and they're called complex conjugates. So those numbers are found up above or down below the x-axis. So you do have zeros, but they're just not they're not real numbers, so they don't show up on our real graph. Alright, so we're going to do an example. Keep all this stuff in mind as we're doing it, and it will help you identify what kind of graph you're looking at. Okay, so here's the equation that we're given. First step is to make sure that this whole thing is equal to 0. So if I'm going to do that, it's not a very good 0. I need to move 5 to the left side of the equal sign so that we get 2x squared minus 4x minus 5 is equal to 0. Just like when you're factoring, you want everything equal to 0. Now I'm going to try and simplify or substitute in just my discriminant. So you can do the whole quadratic formula, and we'll work on that in the next part. But for right now, I just want to do the discriminant. So I need to identify my a, b, and c. Well, a is the number in front of x squared, so that's 2. B is the number in front of x, negative 4. And then c is negative 5. So starting with b squared, we have negative 4 squared minus 4 times a, which is 2, times c, which is negative 5. Now, order of operations is so important here. Most people screw up a tiny part of this and then their whole answer is wrong. So firstly, when I have a negative value that's being squared, remember it turns positive, so positive 16. If you're doing this in your calculator, make sure that you have parentheses around negative 4. And then this next piece, all 3 numbers are multiplied together. Here I have a negative 4 times 2, so negative 8 times negative 5, which would give me positive 40. So here I'm going to be adding 40. Negative times a negative gives me that positive number. So we get a discriminant of 56. right? So we don't know what our roots are yet, but let's go see if we can figure out just what type of roots we would have, knowing that our answer, our discriminant, is 56. Well, 56 is positive, so that puts me in one of these areas. But 56 is not a perfect square, so I am using this section here. So that tells me that we're getting two real irrational roots, meaning it crosses the x-axis twice, but those numbers are going to be very, very crazy. And you can see that right now if you put the square root of 56 into your calculator, it's going to give you a pretty interesting answer. So that's all you're looking at for this, is to find your discriminant and then determine the type of roots you would have from that. So go ahead and begin your assignment 15.